Generally, L2s are very interested, but as I said, they have very distinct profiles. And the real world example I'd like to give here is, the EU a little bit. You did have a leading L2 there, England, and they opted to, stay out of the EU. A lot of large corporations that are, creating a new headquarters are now doing it in Ireland, right? So because of ease of interoperability, if you will, it's very easy for that worker to migrate to the headquarters in Ireland, whereas they have to get a visa and a whole bunch of headaches if they have to go to England. So I would think this would pertain to L2s as well.
Hey everyone, this episode is brought to you by Sei, the blazing fast parallelized blockchain which is unlocking Solana-like performance for the vast ocean of ETH devs out there. Now, you're going to be hearing all about Sei and their new V2 upgrade, but if you take away one thing, the EVM is here to stay. There are some problems with it, which we're going to get into later in the episode, but Sei, and especially their V2 upgrade, is helping solve that. So thank you very much, Sei, for making this episode possible. Hey everyone, this episode is brought to you by Uniswap, delivering the best on-chain trading experience in crypto, period, bar none. One thing I want to call out is the Uniswap extension. So say goodbye to these days of these annoying sort of pop-up wallet extensions. You lose your place trading, you have to open it back up. Uniswap now has a nice, sleek sidebar that persists no matter where you are on the web. It's much easier to use. If you click the link at the bottom of this episode, you can join the waiting list. And I'll see what I can do to get you moved up that waiting list. But definitely go click the link, check it out. If you're building anything in Web3, you likely need oracles and verifiable randomness. That's why Bellcurve is partnering up with Supra, which offers the fastest oracles and DVRF free for listeners of Bellcurve for 12 months. And you can get that at supra.com/blockworks. The link there is in the show notes, or stick around. We're going to be talking about them later in the program.
All right, everyone. Welcome back to another episode of Bell Curve. Before we jump in, quick disclaimer. The views expressed by my co-host today are their personal views, and they do not represent the views of any organization with which the co-hosts are associated with. Nothing in the episode is construed or relied upon as financial, technical, tax, legal, or other advice. You know the deal. Now, let's jump into the episode.
All right, everyone. Welcome back to another episode of Bell Curve. Today, Hart and I are joined by Jonas from Chainbound and Murat from PrimeF. Guys, welcome to the program.
It's good to be here.
Thanks for having us.
Guys, we're pumped. Today, we're going to be talking about something that really feels like it's on the vanguard of innovation, which is pre-confirmations. And before we get into that, which is inevitably going to be a little bit of a technical subject, I actually want to start with sort of a state of the union of ETH L2s at the current moment. And obviously there's a lot to be excited about on ETH L2s, but maybe we could actually start with some of the challenges and almost the problem statement that is making folks excited about pre-confirmations today. So Murat or Jonas, whoever's feeling bravest and wants to kick us off, can you give us a state of like what's going on ETH L2s and what are some of the issues that people are looking at that has us looking at pre-confirmations as a solution?
One of the bigger problems right now that a lot of people are talking about is centralized sequencers. This has been a problem for a long time, but decentralizing the sequencer is pretty hard to do, especially if you want like the really good UX that comes from a centralized sequencer. So I think that's one. I think another one is composability, right? So if you have a if each of the rollups has their own sequencer, it's really hard to get at least synchronous composability between them. So I think that's why, like shared sequencing, base sequencing, I think that's why it's a hot topic right now, because it does solve some of these issues. Murat, do you want to add anything to that?
Yeah, I mean, I definitely agree with that. And then what we've also discovered is that there's very different profiles when it comes to L2s. Particularly, I mean, there's optimistic rollups, ZK rollups. Within ZK rollups, there's different types of proofs that are being used. Some generate more data, some generate less data, some have other considerations. Then there's validiums. So it's very hard to kind of paint them with one brush, if you will. So we really need to have some abstraction mechanisms maybe that that pertain to each one of them, and not necessarily solve for a specific type of L2.
Yeah, so maybe to sum some of these challenges up, and we can start to segment it from the perspective of different stakeholders in the ecosystem. We can maybe talk about this from the perspective of the user, right? So from the user's perspective, it feels like the L2 landscape on Ethereum is pretty fragmented, right? It almost feels like the canonical sort of journey is maybe you start on Coinbase, you go to ETH main chain, and then you have to make these weird bridging decisions. Do I go up to Optimism or Arbitrum? Once I'm on Optimism, it's tough for me to get my assets over to Arbitrum unless you're using a cross. All right, Hart. But it ultimately feels like a pretty fragmented landscape, which is a challenge. I think something that we're going to get into that might be more of an invisible challenge, but it definitely still exists, is quantifying some of the risk that you're taking on as a user. And there are different types of risk, but definitely execution risk is one. We can talk about the way that pre-confirmations play into that. I think another challenge, and maybe this is one of the reasons why based sequencing, this idea of base sequencing, by the way, to give a quick definition of that, it's when instead of using an additional provider like Espresso or something like that to sequence the rollups as a shared sequencer, you're actually using Ethereum itself to be a sequencer for the rollup. I think one of the reasons why there's been renewed interest in base sequencing, which is actually not a super new concept, but it's being augmented with these pre-confirmations that we're going to start to talk about, is I think there's a little bit of a concern about, hey, what is the value proposition of Ethereum, right? Where's our lock-in, especially as rollups are starting to transition to becoming validiums and they're using alt-DA solutions, right? Some of that lock-in for where you have to buy ETH in this process is starting to go away. And I think I don't know if you guys have anything to add to it, but I think there's a couple of different ways that we could look at this, maybe from the perspective of different stakeholders. And pre-confirmations are being, this is maybe the background in which pre-confirmations are starting to be a big subject of interest. And I want to get into some of the different flavors of pre-confirmations that exist and define what that is. So maybe either Murat or Jonas could one of you guys give us just a definition of like what a pre-confirmation is, and then we can get into some of the different flavors about how they could be implemented.
Sure. We published this article defining it as a credible heads up before a confirmation happens. And what's notable about this definition is that it's not about Web3 or blockchains. And we give this example of Amazon that fulfills your order when you make an order with Amazon and essentially gives you a pre-confirmation, even though Amazon's not delivering the order. Usually USPS, FedEx, or some other delivery specialized entity is delivering the order. But Amazon's pre-confirmation is credible enough that you don't actually, check USPS most of the time that you make an order from Amazon. It tells you it's going to be there in 2 days. So we like to apply this framework to how we think about pre-confirmations under Web3 and Ethereum as well.
One thing to push on there. So when we go back to like so your credible commitment, the credible heads up that something's going to happen. Credibility here, I think, is kind of an interesting term because there's many ways you could presumably do that. So just to make the difference to the landscape today, where we have centralized sequencers run by the Optimism Labs and Arbitrum Labs, those entities are giving you a pre-confirmation today from their centralized sequencer, where that heads up is basically guaranteed by the credibility of those teams. Do you agree with that?
Yeah, to some degree. And I would say the users kind of abide by that credibility or think it's sufficient, or they don't, and they don't use that, right? So yeah, I agree with that.
Yeah, I guess actually even to go a step back just to make sure the audience is all like clued on what we're talking about. Like when you submit a transaction to one of these L2s, I'll just pick Optimism. When you go to Optimism, you submit a transaction, the centralized sequencer is giving you a pre-confirmation that your transaction did succeed or not and is going to be included. But you don't actually know that fully until, well, there's a little bit of a pipeline there until it's checkpointed 5 minutes-ish later. And then technically you got to make sure that there's not a fault in that checkpoint, right? So just so we're all on the same page.
Yeah.
When we're talking about pre-confirmations, they exist today, but they're coming from their credibility is determined by a centralized entity for the most part.
Yeah, I would say that's similar to Amazon, right? I mean, Amazon gives you, hey, your package is going to be there in 2 days. Any number of events can happen in between. Actually, if you order enough from Amazon, sometimes those packages don't get delivered in 2 days, or it's the wrong package, or it gets delivered to somebody else and all that. But that that takes away a little bit from Amazon's credibility, but it still keeps it 99% more or less, right? And next time you're making an order from Amazon, yeah, you do recall that one time that things went wrong, but things still go through most of the time. So I would say it's akin to that.
Okay, Murat, I like that. I really like that example of Amazon. I'd actually like to expand that definition and even say, like, when you make a payment with your Visa credit card, Visa is also giving you, in a sense, a pre-confirmation, because that actually hasn't been really settled, right? These are sort of payments networks, which is the equivalent of like the TradFi equivalent of L2. Those are all going to get batched and then submitted to a bank where that's ultimately going to end up being settled. So just like in the world of MEV, where, you know, I know Hossi will talk about like Google ad auctions as a form of MEV. Like, honestly, you could kind of look at that same thing and say you get pre-confirmations everywhere. I would love to get a sense of, you know, when you're looking at someone that's giving you a pre-confirmation, what is the advantage that they're getting? And then what risk or cost are they taking on as well? Maybe Jonas, I don't know if you have a sense there, because I think one of the ways that you could look at the different flavors of or models for pre-confirmations is who is giving you the pre-confirmation, which ultimately begs the question, why is that in their benefit, in their interest to do so, right? So like, what is the advantage and maybe cost that they're taking on there?
Yeah, I think so. So currently, centralized sequencers they would give pre-confirmations because it just enhances UX, right? It just makes using the rollup a lot smoother. But in a base rollup world, there do need to be some like incentivization for different entities to give out pre-confirmations, and I think a lot of that is translated in the pre-confirmation tip. So the idea today is to add like a different tip that can be priced like any other way that would pay a certain pre-confer or the entity that is pre-confirming at that time an additional fee for actually giving out the pre-confirmation commitment or promising to include it at a certain time in the future.
So actually, I'm going to keep going backwards here just to make sure all the users or listeners are on the same page. So what we have today with rollups, I want to know if you guys agree if we separate this into two parts, where the rollup is making transactions cheap by effectively aggregating and compressing them off chain and then checkpointing on chain periodically. But that in and of itself is actually very slow. So a rollup today, if we don't include a pre-confirmation, you might get cheap transactions, but the UX is shitty because it'd be very slow. Um, and then what we've done to make the UX good, so we want for the UX, we want it to be fast and cheap. So we figured out cheapness by doing this L2 compression. To make it fast, we have to add in a pre-confirmation that says, yep, with a high degree of certainty, your transaction is going to be included and is going to succeed. And right now, centralized sequencers are doing this function for free, effectively. They're not really getting paid to do this. They're doing it because they want their L2 to be the one that wins or whatever else, highly competitive marketplace for it. So they're centrally sequencing these things and delivering pre-confirmations for free. And that works today, although you are trusting those centralized sequencers. What we're going to be talking about is other mechanisms to deliver pre-confirmations outside of a centralized sequencer. And those, Jonas, what you were talking about, those other mechanisms, there's going to be some costs. We're going to have to pay for them somehow. And that's both to decentralize the sequencer and then maybe to add in other UX benefits like cross-chain composability. Agreed?
Yes, I think that's right. And like initially, it might seem strange that you have like centralized sequencers giving out pre-confirmations for free, and then like decentralizing the role, and all of a sudden you might have to pay a bit more for like a pre-confirmation. Uh, and like at first, I think it's intuitive that decentralization will cost a bit more, but hopefully by having all of the advantages and like composability that shared sequencing or base sequencing brings, in the end, it might be worth the cost or actually cheaper than a centralized sequencer. But we'll have to see on that.
I would say that the cost is likely to increase as there's more actors that need to coordinate in some shape or form. But perhaps we can abstract some of that and have still or deliver still a similar UX to the end user.
Murat, I want to add like one silver lining bit to that too, which is like in a very technical way, as I understand it, blobs are very large. So blobs are what's making L2s very cheap now. Blobs are very large. They're actually much, much larger than they like need to be for any individual rollup today. And so maybe there are ways to actually make the cost of this decentralized pre-confirmation not any higher because we are like sharing blob space, maybe.
Yeah, the overall cost can go down, but the pre-confirmation cost maybe can go up incrementally, but that's negligible regarding the overall cost. So that's very feasible. Yeah.
So I want to get a sense of what are some of the who are some of the different entities that could be acting as a pre-conf or issuing these pre-confirmations, and maybe that's a good way to segment into different models as well. But one proposed solution that we've been sort of talking about is based based pre-confirmations, where the L1 proposers are actually the issuer of pre-confirmations. But then you could also look at it from the standpoint of maybe a builders who are building these blocks. Realistically, there are like 3 of them today. They're the ones who are issuing the pre-confirmations. And maybe we could get into, I think actually, if I'm correct, maybe speaking a little bit too broadly here, but Murat, your solution, PrimeF, kind of started from the perspective of approaching builders to get them to issue pre-confirmations. And Jonas, you approach it a little bit more from the base pre-confirmation standpoint. So maybe, Murat, can we start with you? Like, what is the sort of explain the sort of model behind getting builders to order pre-confirmations? How would that actually sort of work logistically? If you could just get us into some of the more technical description, and then pros and cons would be really helpful as well.
Yeah. So I have a product background, right? So I've been a product manager for 7-8 years at least, and I'm a firm believer in asking users their problems and what they need. When I was a product lead at Block Native, and we had about 10 to 14% of block building power on Ethereum L1 right after the merge, the number one kind of request or question I was getting from searchers was that, can you guarantee me next block execution? So I want my transaction to be in the next block that you're building. Well, as someone who had 10% of the network, that meant 90% of the time I can't give you that, and that was problematic. And at the first Mev Boost stewards gathering at DevCon Bogota, I raised this issue and put out this idea that what if we had a network of block builders that these users could interact with, and the network could give these guarantees, even though each individual actor might not be able to. And this was interesting enough where lots of people encouraged me to pursue this idea. It eventually, I founded PrimeF, and it eventually became Mev Commit, which is this network that we've been developing to facilitate this. But yeah, the fundamental issue there was, how can we let these consumers of block space kind of get these network level guarantees on being in the next block? And we weren't naming this as a pre-confirmation at the time, but this is a core user problem that I started with, along with my co-founder and others, on a journey to solve. So that's the angle that we came in. After a year and a half, there's been lots of or the expansion of the design space for pre-confirmations. The roll-up ecosystem proliferated. Blobs are a thing now. There's all sorts of different pre-confirmations that we're learning about and kind of researching. So the design space is very, very large, I would say. But yeah, that was the angle. And because builders have their own mempool and have the ultimate visibility into the mempool, if you will, for their own sake, each builder is in the best position to make the decision whether to pre-confirm a transaction or not. Now, this pertains more to DeFi transactions, I would say, and trades. And there may be other actors like relays or others that are in better positions to pre-confirm other types of transactions.
Okay, that makes a ton of sense to me. I think one challenge there from that standpoint would be, okay, makes a lot of sense. Builders have an enormous amount of visibility either into the public mempool, but also whatever sources of private order flow that they're looking at. So they probably have the most confirmation, or the most comprehensive view of all the transactions at any one point, which will allow them to price. I actually have a lot of questions about how you price pre-confirmations. But one of the challenges there is that ultimately all this is going to have to settle down to ETH, and the entity that has the monopoly on the next block is whatever proposer ultimately ends up getting selected. So I would assume there'd be some kind of liability of, if this builder is issuing all these different pre-confirmations, they can have really granular understanding of how to price that, but they still can't guarantee that those transactions are going to land. So I would imagine that there'd be some amount of liability there, right?
Yeah, exactly. And this is how we came up with this fulfillment consortium model, where let's say there's 3 large builders that more or less build all of the blocks. And if all of them give you a commitment, then you don't need the proposer's involvement really. However, this is further strengthened if the proposer is involved as well. If the proposer will say, "Hey, I will ratify a block that comes from someone who is committed to this transaction," then the commitment becomes ultimately credible. Essentially, that if I'm making an Amazon order, that USPS will deliver this order, whatever it is. So ultimately, it's a coordination problem that you want all of these actors to coordinate. And like if I could wave some magic wand and have every actor along the MEV pipeline give me a commitment for my transaction, I would love that, right? So it's not even just the proposer, because the proposer can say stuff, but someone can deliver a malicious block. They can accept it. It can be invalid because there's an optimistic relay. And there's all sorts of things that can go wrong along the pipeline. And ultimately, you want everyone's word that this is going to go through. It's not realistic to get everyone's word, but we can get close to it by coordinating these actors.
Yeah, I think that makes sense, and I think like we started more from the proposer sense, but which like initially makes sense because they are, like you said, Mike, they have like complete monopoly over the block, or almost complete monopoly, I should say, and so they can like promise to include something with more credibility, I believe, than like three builders. But it's true, Murat, if you include a proposer as well, that might not be a big issue. But the thing with like involving L1 proposers is that you still want them to remain somewhat decentralized, and the way you do that is by not upping their duties to running like L2 nodes and by pre-confirming and sequencing L2 transactions. So there's a bit of a dichotomy there. And so what we're looking at like at Chainbound is how can we create something that looks like PBS, that creates like an outsourceable, like a market for outsourcing these more sophisticated duties like sequencing, like pre-confirming, but still having the L1 validator like fully commit to including whatever they promise to. And this can be done by using technologies such as eigenlayer and restaking.
Yeah, the other thing I'd like to add to that is this idea of multiplicity. There's a lot of research going on to kind of break the proposer monopoly. And when you have multiple proposers that are building or proposing a block in a slot, then you can't rely on the proposer commitment as much, or you might need a commitment from all of them, and you might still end up in a situation where you get commitments from 2 out of the 3 proposers for that slot, etc. Right? So coordination still becomes a very key or fundamental issue that needs to be solved when it comes to these future-proofing these solutions.
So if I'm to summarize, just generally speaking, Murat, your design is like, we're going to get block builders and maybe proposers to join into a P2P network that you're calling NevCommit, which I like the name.
Not really. We're saying anyone who has any credibility in getting a transaction on chain, including a relay, including possibly a solver or searcher in some cases, and we have some bridge examples that this pertains to. We say this is an open agnostic network to any provider of execution services, and then they can come in and perhaps there can be a scoreboard one day, similar to how there's one for MEV Boost, where these are the most credible actors whose commitments you want to trust, if you will.
Okay, but you have the coordination problem where, in order to make the UX of this experience good, you want that commitment to happen in a short number of blocks. Like, let's just say the sooner the better, right?
In near real time, basically, you want it to happen as soon as possible that you send a bit.
Yeah, and if you don't have like a big proportion of the actors involved to make that execution guarantee happen, there's a coordination problem until you get to that. Like, there's probably a critical threshold at which this sort of works well, right?
Yeah.
And then, Jonas, your solution, kind of with like eigenlayer restaking, is you're looking to get most proposers running like an AVS software, so an eigenlayer AVS, that would offer similar sort of execution guarantees, and they'd get slashed if they don't do this. But you also have a coordination problem in a sense in this design too, where we need like enough of the proposers bought into this design in order for these execution guarantees to be timely. Yeah?
Yeah, I guess it depends. Like if you want to do so, let's also maybe talk about the distinction between L1 and L2 pre-confirmations. I think that would be interesting. So if you want an L1 pre-confirmation, you can only get it from the proposer that's next in line. Because like if you get it from proposer n+2, the state might change, you might get a commitment, but it can't really be enforced. But if you're talking about L2 pre-confirmations, like what you can do is have like a delayed inbox and maybe a priority inbox where the priority transactions, so pre-confirmation transactions are committed to, and when executed, they have priority over all of the non-pre-confirmed transactions, which means that essentially, like the L1 proposer that is opted into this can give out pre-confirmations for multiple slots, and then make sure that these pre-confirmations are executed before any non-pre-confirmed transactions, which allows them to fully manage the state that they're pre-confirming over.
So just for me to push on that, to help again the audience kind of understand. So let's just make this about issuing pre-confirmations for one rollup. We'll call it like Mike's rollup, and you build an AVS where you have 10% of the stake committed to this. So like roughly 1 in every 10 blocks. They are the ones that are going to be sequencing Mike's rollup. So they're going to be committing Mike's rollups, call it every 10 blocks.
Yeah.
And you're saying that network, so that system of proposers now that have opted into this EigenLayer AVS, they could be issuing pre-confirmations in real time, and then any one of the proposers of one of those blocks that doesn't honor that set of pre-confirmations, they'd be slashed, and that's kind of their credible commitment. Is that roughly right?
Yes, that's right. That's exactly right. And I also want to say that, like, if your proposer is 10 slots in the future, that's not necessarily the time when the L2 batch will be settled or the pre-confirmed batch will be settled, because if they commit to let's say they fill up a whole blob worth of pre-confirmations, they can just push it to the mempool and get it included by any of the proposers or block builders ahead of their slot. So they can actually start settling faster than their own slot, which also like helps with finality. It's a caveat, but I think it's maybe important to mention.
No, but basically you're saying, so in Mike's rollup that's being sequenced by this AVS, you're saying that the network of the 10% of stake that's sequencing Mike's rollup, they could just be issuing credible pre-confirmations, credible commitments to transactions in their own kind of P2P network, if you will, filling up a blob. And as soon as the blob is filled, then that gets sent to Ethereum mainnet and committed. That's what you're saying?
That's right. Yes.
Yep.
Yeah.
Cool.
One other thing I'd be curious. I think this presupposes the ability, something like inclusion lists, right? Of proposers to be able to say like, yes, they have to have the ability to, once I make this confirmation, then I have to actually have a guarantee on the other side of things that builders will actually include these lists, include these transactions in their block, right? I think that's a necessary bit of infrastructure for this to work from the based pre-confirmation standpoint. Jonas, correct me if I'm wrong there.
Well, if we're talking about L1 pre-confirmations, then yes, the proposer needs to communicate it with builders. But if we're talking about L2 pre-confirmations where sequencing is distinct from like PBS on L1, it's a bit different. Like the sequencer has a full rights to order transactions and doesn't actually need to communicate with builders because they can just build the L2 batch and then include it in the mempool either way. I don't know if that makes sense.
I was talking about it from the L1 standpoint, because my understanding, right, to like maybe bring this, like start to add a little bit of context outside of how this is technically going to work is right. I want to now talk about this a bit from the standpoint of this is using Ethereum as a sequencer to add to the value proposition of Ethereum. And I feel like this is a big part of why folks are excited about this, because one, there is frankly an element of like appreciation for ETH, the asset, right? Which is like, we want Ethereum to be useful as a technology platform, and that should theoretically translate into number grow up technology for ETH. The other thing that this is supposed to be help out with is you're expanding the value proposition of Ethereum, the platform, as being responsible for interop, because interop's been, at least from my standpoint, the largest drop ball on the ETH rollup centric roadmap. We don't really have a great solution for this. And I guess one thing that never really comes up in these discussions, but is something I'm like very curious about, is what does the incentives look like for rollups to adopt something like this? Because this is where I think people tend to immediately take the perspective of either Ethereum, the network, or the user, and say, hey, this is great, right? Like, we get to use Ethereum for more stuff, so that's good for ETH asset. And I'm a user and I want synchronous composability across all these rollups, right? Win-win. But you're forgetting about one critical stakeholder here, which is the L2, and something that I'm starting to gain quite a bit of. Right, this has been a really tough BD sell from some of these shared sequencing networks to onboard, and the reason is because their incentive actually runs counter to this. Right, they see themselves as originators of order flow, and if you're a leading L2, it's like, yeah, I understand why everyone wants to be integrated with me, but what's my incentive to share all my valuable order flow with all of you? And, there's I think another argument that you could have on the base sequencer side of things, which is like, hey, right now, even though I'm theoretically taking on some amount of liability, issuing pre-confirmations for my centralized sequencer, I'm getting quite a bit of value, right? I'm building a network effect, and I'm happy to underwrite some amount of liability if it's getting me much more sticky users on my network. And there's actually a great, I saw a couple of questions on Twitter. Buffalo from Gito was asking, what's the incentive from the L2 standpoint to adopt these based pre-confirmations? Because it does feel like you're seeding a little bit of value prop. And I would be curious, like, Murat and Jonas, from the two of you, like, what has the reception been from the L2 standpoint on all of this?
Yeah, I mean, generally L2s are very interested, but as I said, they have very distinct profiles. And the real world example I'd like to give here is, the EU a little bit. You did have a leading L2 there, England, and they opted to, stay out of the EU, right? So, but at the time that seemed like a good decision for them, maybe. But what you're seeing is a lot of new corporations that are spinning up, or a lot of large corporations that are creating a new headquarters are now doing it in Ireland, right? So because of ease of interoperability, if you will, if they have a worker who's in another EU country, it's very easy for that worker to migrate to the headquarters in Ireland, whereas they have to get a visa and a whole bunch of headaches if they have to go to England. So I would think this would pertain to L2s as well. Yes, there might be some very large L2 that opts out of this protocol, but over time, the interoperability benefits would accrue towards the ones who are using this shared system or synchronous composability in one way or another. I don't think it's going to kind of kill the other L2. I think that large L2 will still continue to thrive, but I do think it'll be consequential to them. Making this decision will basically be consequential at some degree.
I think there's also a point to be made. So let's for a minute presuppose that all of the execution fees in a base or in a shared sequencing world also go to the rollup. So as it is right now, I think there's a case to be made that if you have more composability with other rollups, that might actually increase execution fees on your own rollup, because like a lot of transactions are made possible by like composing multiple rollups. So I think an argument for that can be made, but then also just more on the regulatory side, like if you run a single sequencer, that might become a problem for you in the future, and which is not great, like for your rollup either way. So I think, like from a regulatory standpoint, it might be just smart to start thinking about outsourcing this to a World War III resistant network like the Ethereum L1.
All right, I'm just gonna tee you up here. I know you've got some strong thoughts on this. I'd be curious.
Oh yeah, no, I so Mike and I were joking about this beforehand, because it's like the decentralization for regulatory reasons, I think is it's a forward thinking argument, but I basically say, like, the rules here are so unclear. It feels like it's hard to put that as the primary motivation for doing something. It's like right
Correct.
now, people bring up like a money transmitter problem, but like Circle with USDC and their CCTP protocol is already letting anybody move money between chains. I thought that was a regulatory risk for them as like a money transmitter, but they like apparently got comfortable with it with lawyers and whatever else. So my point is that it's just I push pretty hard on the uh, do this for regulatory reasons because I just think it's like the least clear argument. I do agree though with do this for robustness and like liveness considerations to make sure something
Right.
can't get shut down. That I very much agree with too. So like, one of the arguments, like if you really dig into how some of these centralized sequences are set up, I think publicly Arbitrum said, they run two sequencers that they could hot swap at any moment, and then they have like three others geographically placed in different parts of the world. Seems okay, but like not great from a kind of like robustness perspective. So that's my only.
Right.
Mike was laughing because he was pushing as like decentralization for regulatory reasons is like a pet peeve of mine.
Yeah, no, I think that makes sense. Yeah, maybe the liveness reason and like the composability reason is stronger, at least now, because we're not really sure what it's gonna look like in the future.
Yeah, one something else maybe to agree with Hart from a slightly different angle is one of the criticisms that I personally think is somewhat fair, is if you try to decentralize everything that's going on L2s as much as it is on Ethereum, it's kind of like, what's the point? We're now is this a little bit of a hat on a hat situation where we already have Ethereum to be extremely decentralized? If you layer another Ethereum scale, World War III resistant system of decentralization on top of that, I would push folks on this podcast to explain to me how that isn't going to add cost. I feel like it has to add cost almost definitionally. And isn't the whole purpose of having Ethereum be as decentralized as it is optimizing for solo stakers, things like that, very low hardware requirements, so that we can push the limits on the layer twos, right? And actually be a little bit more efficient because we've got this base layer of decentralization. So what would you say to some of these critiques that sometimes get levied at shared sequencer designs or, running auctions on top of auctions that were kind of needlessly adding a lot of cost and complexity here?
I'd say, I originally had this auctions on top of auctions view, not good kind of view. But I'm increasingly seeing that in real world, there's many auctions on top of auctions. And when you think about it, like settlement and TradFi is one example of this. Like we gave this example of Visa giving you, a pre-confirmation, but really the money settles with the bank, 3 days later or something. Well, guess what? That bank's money actually settles with another bank like 2 days, 3 days later, and that bank settles with the Fed in a few days later, and the Fed settles with the other Fed a few days later, and it's like this whole kind of layers of abstraction of the settlement. But the system works in the sense that, like, when I go to the store and buy something, I'm able to purchase it, and at the end of the day, that's what I care about as a user. So I feel like there might be a similar case here where maybe we do have auctions on top of auctions. Maybe a bunch of these auctions get replaced by something like a single unified auction, Suave, and that might be good. But at the end of the day, if we deliver the experience that users need, then I think a lot of this is just going to be running in the background, and then we can let the free market figure out which one's better. And I feel the same way about L2s being, a centralized sequencer or a decentralized sequencer. I do think there are ways to decentralize your sequencers beyond making it centralized today. You can just have like two sequencers, and one could do it for one day and the other could do it for another day, for example, just like some basic level decentralization. And you can kind of progress from there if you wanted to. But I do think that the inaction we've seen on this front and kind of action being more on the research side, points to the fact that this is not a number one concern for the users that are using those chains. Maybe I'm wrong, but that's what it seems to me like.
Yeah, and I
So
think the World War III. Sorry, if I can add, a little bit to that. I think the World War III scenario is like unrealistic in a way. It's touted as one of the big advantages, and it is in a way. But if you want like a very efficient system that can level or that can achieve the same level of efficiency and UX as a centralized sequencer, you're gonna have to outsource things to sophisticated entities. So in the end, it's not gonna be completely run by, or at least in my view, by the L1 by the L1 proposers. There is going to be some level of outsourcing and sophistication, but it's going to be better than the status quo. That's kind of the way I think of it.
So I want to push for a second just on like what the users actually want here again, just playing off some of the points you guys both made here. So, okay. First off, one question for you, Morad, because curious your thoughts on this. From an L1 perspective, do users really on L1s? My sense is users don't demand pre-confirmations faster than like what they're currently getting. They're like kind of used to this 12-second kind of confirmation time.
Depends on who by user.
Yeah, so I'm saying users clicking around transactions in their MetaMask, like that's what they've kind of gotten used to. Do you disagree with that?
I do think it would still be an UX enhancement, but the users I'm thinking of that who need L1 pre-confirmations are actually L2 sequencers who are trying to get their blobs on there, and likely searchers who are doing atomic stuff, or stat arb or other things, right? So it just depends on the user class that we're talking about.
So on that, I actually saw I watched your ETH Denver talk, and I think there's an interesting and fairly nuanced point here around like blobs getting confirmed on L1 as blob usage goes up, and because like latency timing games related to MEV. So just to push on that point for a second, what you're concerned about, which I think is a very valid concern, is that we've introduced blobs. It's made L2s very cheap for the time being, but these blobs are huge bits of data relative to the network, and propagating them at like MEV speeds is very hard to do, which means we now have a risk that at times of high congestion on Ethereum, blobs might get dropped or might have to pay fees equivalent to like L1 gas fees, and basically their cost advantages will go away. Is that right?
Yeah, pretty much. Basically, we've ignored this kind of dollar per kilobyte real metric that's going on, basically.
Okay, so there's a very real point here from like kind of like a MEV and cost efficiency perspective, that without something else getting figured out, blobs could actually get really expensive in times of high congestion, and pre-confirmations on L1 would be one way to solve that. Yeah.
Yes, and really the important point there is that when you pre-confirm something and everybody on the network knows it, they can transfer that data ahead of time, and that's really the kind of the disengagement of the timing game from the size of the blob. So
Okay.
yeah, it's not just the UX that the pre-confirmation provides. It's that when the knowledge is there by network actors, the network can take actions to do things that it otherwise would not be able to.
That argument makes perfect sense to me from like a network efficiency and like I'll call it MEV, but it's like network efficiency type perspective.
Yeah.
If we bring it though back to the multi-chain kind of theme of the season, things we know we need for L2s is we need fast pre-confirmations, which we are currently getting from centralized sequencers, and we're like a decentralized version of that seems better. How much better the decentralization of that centralized sequencer is sort of a topic of debate, where I think the primary pros for it are like liveness and regulatory concerns. And seems like the primary con would be there's probably some added cost. And then the other major benefit would be some form of composability that a shared sequencer could give us. And then Mike's other point here is also like Ethereum value capture, where if we make Ethereum be the central hub for sequencing everything, that seems good for Ethereum value capture. Am I missing anything here?
No, I think that's very much in line. I mean, ultimately, let's say you're at some vending machine and you want a can of Coke. Like, do you want to wait 12 seconds for that can of Coke, or do you want it now? So if we can enable for people to get their can of Coke fast and as they want it, I do think that's a net positive for Ethereum adoption in very kind of mainstream use cases. And chances are that vending machine might not be even aware that it's using Ethereum underneath. Maybe it's using some sort of card network that is an L3 and it's rolling up to an L2 that's using Ethereum, right? So yeah, I do think it's a net positive for Ethereum to be able to provide these experiences.
Yeah, my only push is that in the world we're going down on Ethereum mainnet, it's kind of like we've kind of given up on trying to have super fast transaction fee. It's just so expensive. You're maybe solving that, but like most people have already been pushed to like the L2 version if they want fast speeds. That's my only point there. But all the other parts around efficiently 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 allocating resources on the network on L1, the pre-confirmation aspects there make total sense to me.
Hey everyone, wanted to give a big shout out to today's title sponsor, Sei. Now, I want to talk to you guys a little bit about why I think Sei is cool from a design standpoint, a big problem that it solves for ETH devs out there, and then some cool stuff that Sei has coming up. The reason I like Sei from an architecture perspective is, again, it's a very fast blockchain, parallelization, all of that stuff, but Sei has essentially been custom building block space, which is for consumer apps and dexes. Now, they have some very cool features which enable that. So twin turbo consensus, optimistic parallelization, Sei DB, all of this stuff allows you to reduce the time to finality, make for very, very fast transactions. So if you're building a consumer app or a DEX, this is basically the blockchain for you. If you've been building in the EVM, you love the EVM, but there are some restrictions about it that don't support your app. So maybe you can't do fast enough transactions or it's not parallelized, whatever it is, you can now take all that stuff that you built. You don't have to start from scratch and you can build it on Sei. Now, recently they've launched V2, but also public DevNet. So the way that you can follow that and keep up to date is go and follow Sei Network on Twitter. All right. Thanks, guys. Hey, everyone. This episode is brought to you by Uniswap, delivering the best on-chain trading experience, period, bar none, in all of crypto. Here's how I would divide the protocol today. There's a web part, a mobile part, and an extension part. You can say goodbye to the pop-up wallet extension. It's just not great from a UX perspective. Now what they've delivered is this nice, clean sidebar where you can just very easily track swaps, sign transactions, send or receive crypto anywhere. Just a huge UX improvement. On the web part of it, huge improvements here. You can buy and sell 700 plus tokens at your price on your terms. And they've got limit orders, which are powered by Uniswap X, and there's gasless. They've also got real-time charts, transaction logs, pool data, project information, all this cool stuff that just really improves your UX trading on the web. And again, all of this is powered by the smartest protocol in terms of Uniswap or Uniswap X. Click the link at the bottom. Uniswap extension is in alpha right now, and we'll see what you can do about getting you moved up that list. Thank you very much, Uniswap. Hey everyone, this episode is brought to you by Supra, delivering the freshest Oracle price feeds across 50 plus blockchains. When it comes to crypto, speed and security are both critical, and luckily for y'all, Supra has you covered on both of those things. Be that for liquidation triggers, critical price levels, whatever it is, Supra's got your back. The other great thing about Supra, they love listeners of Bell Curve. So they're going to hook you guys up with 12 months of free Oracle services and verifiable randomness. They call it DVRF, centralized verifiable randomness. So 12 months free. You just got to go to supra.com/blockworks. Two more cool things about Supra. They're really secure, easy to integrate. They run on 12 times lower gas speeds than other Oracles out there. So you're going to save on that as well. And if you're listening and you know builders that need services like Supra, you can actually refer them and get $1,500 in referral. So to get all of these goodies, you just got to go to supra.com/blockworks. And again, the link there is in the bottom of the show notes. Click that so I know that I sent you. Cheers, guys. Are users going to care where their pre-confirmation comes from? Right? I think like that's maybe what you're getting at a little bit, which is like I, as a user, I place some some swap on a DEX, and I'm either going to get, actually, there is one source of one potential pre-confer that we haven't talked about here, which is actually Amazon in your example, Murat, which is the app. The app can issue these pre-confirmations. And ultimately, like I'm sort of an app maxi. Like my assumption is that, when we talk about users right now interacting with like Ethereum or Rollup or a sequence, like all that's going to be invisible, right? Like the only emotional connection in the end game is going to be with apps. So actually, there's probably a very likely outcome that the relevant pre-confer from the perspective of the user is the application. And like, I guess if I had to like push a little bit in terms of like when I hear this like base sequencing talk and Like, yes, I understand because I have a rough understanding, 5% of what you guys understand, but I have a rough understanding of like the network design and the actual assurances that you get from a pre-confirmation issued by an L1 proposer as opposed to a sequencer or an app. But is a user going to understand that? And are they going to care? And I think maybe, Hart, that was behind your question about like, we've already pushed a lot of people off of L1. They're already getting these pre-confirmations from sequencers. Like, where is the pressing need for them to get adopted by L1 pre-confirmations?
Yeah, I mean, I would say ultimately, like if we go back to the Amazon example, like you do care if it's Amazon, and if Amazon gives you the word, then you're fine, right?
Yeah.
If there were some other entities that Amazon said, hey, look, johnnydelivery.com is telling you it'll be there, you might be like, I'm not so sure about that. But you'll probably piggyback off of, oh, Amazon said johnnydelivery.com is fine, so then it must be, right? But ultimately, the destination or I guess the source of your pre-confirmation does matter from credibility standpoint. But yeah, I agree that apps are in a great position to deliver this for their apps. We've actually talked to an app recently who wants to utilize Mav commit pre-confirmations for their app. Basically, for their app, they would be the only ones who can credibly issue pre-confirmations, and if not, the transaction would revert when it comes to that app. So there are already mechanisms that dApp developers are kind of thinking about to do their own pre-confirmations. So yeah, this is a modular world, right? So everyone should be able to give the user experience that they want for their users.
Yeah, I think applications giving out pre-confirmations is that should also work, but they must collaborate with people further down the stack to be able to provide credible pre-confirmations, right? Like, for example, yeah, the example from Murat, like they need to have some sort of assurances that they can actually execute the pre-confirmation. And on that, I've seen a lot of talk recently about like application specific sequencing, where an application sequences all transactions for their specific state. And in that case, like the application would be in a very good position to give out pre-confirmation. So yeah, maybe related further research.
I've got a question on this is going to sound a bit like a technical question, but I do think it's pretty relevant. Is one of the in most of the implementations that I've sort of seen sketched out about this, there has to be some sort of pre-confirmation tip, right? Consider this like the priority, like analogous to the priority fee that users might pay interacting with ETH-L1. You have to pay a tip to the issuer of your pre-confirm. What does the how does that pricing work? And I actually see challenges from the perspective of like, if you're a builder issuing that pre-confirm versus if you're an L1 validator. The challenge that I see on the builder side, Murat, I think you might have an answer to this actually. That's a pretty cool answer. But the challenge is it actually runs counter to, it's kind of like the difference between an ex post and an ex ante auction, right? Like what we see in MEV on L1 is builders want to wait as long as they possibly can before they actually end up submitting their block, because the longer you wait, the more information that you have and the more profitably you can build a block. You want to drag out the time that you're running this auction. So if you, how are these builders then pricing, right? Pre-confirmations that get issued like, I don't know, half a second into the block, right? And isn't that kind of against their interests? I think you know the answer on the builder side, but actually, why don't you answer that? And then I've got a separate question for the L1 proposer side of this.
Sure. There's been an uncomfortable truth when it comes to pre-confirmations, and that, if users want, as soon as possible pre-confirmation. So as soon as they send a tip or transaction, they want the pre-confirmation. And then, it's in the best interest of the builder or proposer to wait until the end of the slot and then to give all of these pre-confirmations. So, we've come up with a decay mechanism on MEV commit to kind of combat this. Basically, as soon as, let's say, you bid 1 ETH, for your pre-confirmation bid, it starts decaying in real time. And then there's multiple entities that are competing to give you a commitment, right? So basically, if there are 2 builders and one gives you a commitment right away and the other waits till halfway through the slot, now the builder who gave it to you first essentially has a monetary economic advantage on what their block value might be. So they're competing and they're incented to give it to you as soon as possible. Now, this may still lead in situations where your tip isn't just not high enough and you're not getting a commitment, or you're trying to get a pre-confirmation on a very contentious state that no one's going to really give it to, and then you have to deal with that. But when it comes to pricing these things, I can go into pricing a little bit more, but maybe I'll pause there to allow Jonas to kind of opine.
Well, I have a slightly different question for Jonas, which is, all right, so this is a challenge. This is a challenge from the perspective of the builder because it runs up against the sort of natural incentives of an auction and pricing. But ultimately, like, builders are really sophisticated entities, right? They've got a ton of money. They've got a lot of expertise. Like, we'll figure out some kind of way to appropriately price this. I guess my question from the standpoint of an L1 proposer is, how is an L1 proposer, maybe more specifically, well, even a really professional staker like a Chorus One or a Figment, like, their internal core competency is running nodes, right? It's not like auction pricing. So how are they going to price this? But then that extends even further to your average solo staker who's, theoretically be some guy living in the woods somewhere running his Raspberry Pi. Like, how's he going to be like, oh, yep, I know how to price this auction? And so how's that all going to work?
Right. So no, that's a great question. I just want to reiterate that we're not like the way that we want to build this is allow L1 proposers to delegate all of these very sophisticated duties to sophisticated actors through something that looks like MEV boost, right? So in the end, what they're doing is providing block space, like guaranteed block space, to allow anyone else to kind of sequence and pre-confirm, etc. So in the end, they don't really have to do all of these sequencing and pricing because we agree that they probably can't. Like, maybe there are some stakers like Chorus One, you said, that could do it, but then you really you run into the problem of solo stakers not being able to do that, and the centralization vectors that creates. So in the end, I think on this question, it looks very similar like Murat, where builders will probably be the entities that are being delegated to, and they're in a position to price this in a much better way.
Okay, then if that is the answer, then I have a question for this entire call, which is why. Basically, the way that I would look at this, and this is sort of a high level perspective that I have on blockchains, like, you can trace the difference in every L1 blockchain to what the role of the proposer should be in terms of its hardware requirements, what it's required to perform. Like, this is what we expect of the proposer's role. I think broadly you could interpret pre-confirmations is Ethereum starting to walk back some of its initial design philosophy of pushing complexity to the edges. And initially the design philosophy for Ethereum was, we want this to be very we want the L1 proposer to be super simple, not very complicated, so we can optimize for solo stakers. And the way that at least I'm interpreting this is, actually, maybe we want them to do a little bit more than we initially thought. And we're not going to put that in protocol, right? We're not going to make it like, we're not going to include it in like a hard fork or something like that, but they can opt in via restaking. But then you're increasing your principal agent problem by just delegating it to a builder. And like, I'm starting to question, like, if ultimately we adopt pre-confirmations, we're asking our L1 proposers to do more than they're currently doing today, but our L1 proposers aren't set up to do that, so then they just end up delegating it to a builder. Why don't we just change the spec on our L1 proposers and just make them bigger and beefier?
Well, I think actually there might be like a slight research trend that's pointing towards that, like with execution tickets, with the separation of beacon chain proposals and like execution proposal, or I think that's a distinction they make.
Execution tickets, I think.
Execution tickets, exactly. And so what it's pointing to is that you want a very unsophisticated, decentralized validator set to be able to enforce censorship resistance and properties like these through the means of like inclusion lists. But in the end, since we're already outsourcing like sophisticated execution to builders, etc., we might as well kind of put it inside of the protocol and separate execution proposers from like beacon proposers. And the beacon proposers would uphold censorship resistance, would keep basically checks on the execution proposers. whereas they would be able to fulfill any sort of like very sophisticated tasks. And yeah, execution tickets is one form of that, but I think there are many. Like there's a post on Rainbow staking, for example, from Barnaby from the EF that I think is super interesting, and it also outlines like a more general design of execution tickets, which is super interesting. Don't know if that answers your question, but
Well, Mike, yeah, like I like it though, and I actually, Jonas, I think I agree with this approach where I think it's okay to have a network where if certain actors go offline, there's like a degradation of service, like things get a bit worse, but they don't stop. And
Break.
so my take on kind of what you're saying here, and even your proposal, is you're saying the builder of these forget the term you're using, but like the builder of these complicated entities, it's being outsourced from the proposer that's running this AVS, and you don't want those guys to go offline. But if they did, the network will still keep operating. And I think that
yeah,
seems like a useful design principle. In the same way that, you know, you want, let's say, equity market. If we do make some TradFi examples, if equity markets, like if Citadel goes offline, they don't break. It just maybe gets less efficient for a bit.
Mm.
yeah, yeah. I think that's a good analogy. Yeah.
One thing to also add here, just in terms of sort of there is the possibility of decentralizing the builder role, which is being worked on sort of by like Suave. I know Vitalik has talked about this quite a bit, but I think there are actual credible, very legitimate attempts at decentralizing that role over a period of time. It's going to be tricky, going to take some time, but I think you could also look at the assumption that builders are always going to be these centralized entities as not necessarily being accurate either. So
Yeah, true.
I mean, we use commitments to kind of have this happen out of protocol. So, you know, for blob pre-confirmations, for example, we think the relay is in the best position to do it. Pricing them is not as sophisticated. You don't have to kind of be aware of DeFi transactions. And then, you know, your pre-confirmed blobs can become an inclusion list for the builder. And then the final block is technically built by the block builder, but you know it had rules enforced by others across the ecosystem where you could proxy a decentralized builder in this way, and you can act in by kind of coordinating these actors you can achieve these goals a little sooner. But yes, ultimately we do need ground up designs that are decentralized by foundation.
Gents, we're in our closing minutes here. I suppose, if we wanted to bookend the conversation here and leave listeners with, I don't know, any sort of thoughts about, this is the multi-chain season, and the thing that we wanted an explanation of what pre-confirmations are, maybe within the context of how it's changing the role of the L1 proposer, how it could potentially solve the interop challenges that we've seen on L2s. We've indirectly talked about MEV. We probably could have done a whole episode just on the MEV implications beyond this as well. But, if you wanted to leave listeners with, one thought or just bookend the conversation that we've had today, hey, what do you want to leave them with?
I would say pre-confirmations are real. They're coming sooner than you think. And they're going to enhance not just UX, but usability of the entire ecosystem for most of the actors, if not all. And it's just a foundational primitive, I would say, that's going to enable all sorts of design spaces. I mean, there was a workshop done by Flashbots where, I talked about a potential of a real-time DEX that's powered by pre-confirmations. There's just many new design verticals that are enabled by this new primitive, and it's a very exciting time to be in Ethereum, I would say.
Yeah, I think maybe what I would say is that base sequencing and base pre-confirmations, the advantages that it has maybe over shared sequencing that we didn't discuss in this call is also L1, L2 interoperability. I just want to say that that's also a huge selling point, I think, for rollups to opt into this, and I think it will enable some very cool features.
Awesome. Well, guys, we really, really appreciate the two of you coming on here and educating our audience about this. It's a super interesting topic, and when you search, which I often do, for things on like YouTube or Spotify, there's just like really not that much content out there about pre-confirmation. So hopefully this can be a little bit of a foundational, explainer for folks. And Murat or Jonas, if folks want to find out more about the work that you guys are doing or follow you personally, like what's the best way for just people to stay up to date with this and find out more about what you guys are working on?
primev.xyz, I would say, and our Twitters also. But yeah, if you're curious enough, you can very easily kind of scour the map from there.
Yeah, it's chainbound.io for us, and we're planning to release some posts also about base pre-confirmation soon to make the things that people can read a bit more interesting as well.
Awesome, fellas, thank you so much. This was a blast. We really appreciate it.
Thank you.
All right, man. That was a great episode. I was a little,
Yeah.
I'll be honest, I was a little nervous going in when you talk about something as technical as pre-confirmations. It's always a bit risky, but I feel like we did a good job of getting into some of the details, but also zooming out as well and giving some context.
Yeah, the thing I wanted to push on is that pre-confirmations do exist. I agree with Murat's definition very much of this like credible commitment, this credible heads up. But you're getting that today from centralized sequencers where the credibility is just their reputation, right? And the fact that they want like their token price to go up, they want to be the leading L2, all that other kind of stuff, right? So optimism lying about a pre-confirmation would be really, really, really bad for them.
Yeah.
And so I think, first of all, I think Murat's push for pre-confirmations on L1, I am a little bit skeptical about whether like users care about that, and I don't think they really do. I think anyone that wants a faster confirmation is going to an L2 today. But I do think his points around how it's going to make Ethereum better from like a network efficiency perspective, and there's some fairly technical bits around blob space, which just made L2s so much cheaper, actually getting very expensive without things like what he's working on. I thought that was a really interesting point, but that's like quite in the weeds too.
Yeah. I thought there were a couple. So I'm in complete agreement with you, by the way, on I personally think this is obviously going to be a technical discussion where, there are different assumptions that go into a pre-confirmation based on who's acting as the pre-confer, right? It's not the same to get a pre-confirmation from a builder versus an L1 proposer versus a sequencer versus an app. But personally, I just don't think 99% of users are going to understand that or care very much is the honest reality. But
So,
I do.
Well,
Yeah.
go ahead.
So, but one of the pushbacks that I think he gave that was good is when we were talking about, is this just a bit of a hat on a hat situation? And are we recreating a lot of the decentralization on L2 of Ethereum that we have on L1? And is it auctions on top of auctions? I think his point was super valid and something that I've waffled on, but I'm ultimately trending towards that, which is like, if you look at the system of how anything works, like there are many layers to it and it does feel really complicated. And, it's very tempting sometimes to look at Ethereum and be like, why does that have to be so complicated? It's like, well, it's a global network, it's a global computing network. And these things do have many layers and different auctions that get run. And it is very complicated. And I thought that intuitively sat really well and made a lot of sense there.
I agree, but I think it actually argues both ways. So both these guys are facing, so when we talk about pre-confirmations for decentralizing L2s, we have, it's like a shared sequencer, a base sequencer type concept. And you have this incredibly difficult coordination problem of how are you going to get these different L2 networks to opt in to the same, I'm going to call it the same concept, the same shared sequencer, the same source of pre-confirmations. And that coordination problem, I think, is really, really tricky. And you alluded to it too, where I think there's a lot of reasons why L2s don't want to give this up. And I think we can go a bit deeper into that. So when Murat was talking about like, hey, yeah, like there are auctions on top of auctions, and like you look at traditional finance, and when money moves from A to B, it goes through like 7 different intermediaries. I'd say like half the reason why that's true though is because there was some path dependency around how traditional finance got built. There were sort of existing systems in place and people that didn't want to let go of control and all these other things that said, hey, okay, no, I'm not gonna agree to this other better standard. You've got to like use my thing. And then somebody hacked together another auction on top of auction to make it work. So I kind of think that point argues both ways, where I very much agree that there's going to be these layers of complexity, but because we have a number of entities that want control and don't want to give up certain rights, I'm not so sure how many of them are going to opt into some concept of shared sequencer or shared to deliver shared pre-confirmations. I'm not really sure how that's going to happen unless the opportunity cost for not doing so is pretty huge.
I totally agree with you. I think time and time again, we've just undervalued this like incentive, which is just natural to humanity. Capitalism writ large is like, I want to do my thing, right? I want to create value in my little area. And it makes a lot of sense. And I think this is where sometimes the folks that are very focused on network design miss this is if you're looking at it from the perspective of Ethereum, the network, and Ethereum, the asset. And by the way, Bitcoin as well, Solana as well, Cosmos as well. Like
Yep.
people tend to really look at it from the perspective of the network, but all of the users and the entrepreneurs and the app developers are looking at it from their own perspective. And those things don't necessarily go one to one. And I think because, again, we're so early and because so many of these systems haven't been built yet, again, we focus a lot on like, how is this actually going to work as opposed to maybe this isn't really a technical problem at all. And it's not a question of how it could work, right? We have the technology. It'd be really easy to make this work. It's a question of how do you align the social incentives? And that I think is where
Yeah.
we need to push more on. Because that's the big
Yeah.
challenge
So
that
on
I see.
that, yeah, no, yes, that I agree with. We're in agreement there. So
Mhm.
based sequencing, the idea of Ethereum being the sequencer for every L2 that connects to it, and having some network of shared sequencing where pre-confirmations come from a single concept, a single mechanism that everybody is bought into. I like that idea. I think that's cool. I'm not sure it's going to happen. And so Murat also made the analogy of like the EU, right? So the EU uh, grouped together to have shared market, shared immigration, all these like good things. And then like England dropped out, right? And I think the analogy for L2s, I think the biggest value prop to opting into some sort of shared sequencing or like based sequencing would be composable interoperability. Um, and this would basically be the idea of being able to do a flash loan between two L2s. I'll use that as my concrete example. And then my push would be, okay, that would be cool and I want that to exist, but is that a big enough need? Is there a big enough need for that these L2s will give up some degree of their sovereignty and some degree of their own sequencing fees and control and all that in order to enable that? And that I'm very unsure of.
Okay, I agree with you, but here's one big wild card that could really influence whether or not this gets critical mass is Lido. And the reason why that has Lido has such an impact is because of the incredibly high percentage of Ethereum proposers that they've got on their network. And if one of these, either Primev or Chainbound or whatever, were to do some very savvy BD work with Lido and get that entire proposer set to opt into this, suddenly right there, you have a really large percentage of L1 proposers. And then once you look at it from that standpoint, it's like, well, maybe I can get this massive percentage of L1 proposers to opt into this thing. And then suddenly I do actually have this very credibly neutral, you could build a lot of stuff with that. You could build an exchange, you could build whatever. Then that's a really compelling value proposition, I think. So I do sort of think if someone were to figure out like how to make that work, that could be pretty interesting. Maybe to give someone an idea about that. Yeah.
Yeah, no, if you get Lido and Coinbase, right?
Right.
If you get like something like that to opt into base sequencing, and there is a place here where like you get good vibes from doing this too. Like
Yeah.
if you get all the intelligentsia in Ethereum pushing for this, and you get the overall like ETH whales and ETH thought leaders to really push for this outcome, I think there's a chance, there's a possibility. But the other approach here, what I think is probably more realistic, is you do have three ecosystems, three main ecosystems. You're probably going to have four ecosystems, or where you're going to have all of the Optimism superchains kind of having some sense of shared sequencing-ish, like some way of kind of doing this, and some sort of decentralized pre-confirmations coming from that system. You're going to have the same thing with Arbitrum, and you're going to have Polygon and their egg layer doing something similar. But those are going to be separate islands, if you will. And then the fourth would be like everybody else that wants to do base sequencing, or maybe you get one of the three other ecosystems to also do basic sequencing. I kind of feel like if I were forced to make a prediction, that's kind of how it would end up. We'll see.
I like that prediction. Hart, what did you make of? I'm conscious of this because I feel like I make this point quite a bit, but that point of, did you agree with that whole point about, we're sort of redefining the role of the L1 proposer. We're asking them to do this. This was originally the observation here, was the way that Ethereum and Cosmos thinks about their validators are totally different, right? In Ethereum, you're trying to make them, dumb and simple and unopinionated. And in Cosmos, it's literally like, what can your validator do for you? Like ask them to do more stuff. And it feels like we're actually swinging a little bit back more Cosmos here, with the important caveat and stipulation that we're not requiring the Ethereum proposer set to opt into this. But again, we're sort of tipping the balance of incentives that I think pretty strongly encourages them. And they did. Justin Drake did address this in his original piece that he wrote, which is exactly what Jonas said, which is that you can delegate your ability to issue pre-confirmations, do all that pricing, et cetera, to builders. And I guess I'm still wrapping my own head around what I really think about this. But what do you think about this changing role of the L1 proposer? Is it a problem that we're asking them to do these things, but then just delegating it to a builder? So it's kind of like, well, why are we even doing that at all then? I mean, what did you think about that whole perspective?
So I actually think it makes sense, and I think it's happening with Eigenlayer anyways. So Mike, I'm pretty sure you're going to do a season on Eigenlayer, and you should, because it's fascinating. But like the whole restaking thing means we're already asking all of these additional asks of proposers, and that's coming. And I think the idea of, well, if I'm now a proposer, I'm a solo staker or whatever else, I opt in some additional set of commitments that I make in my restaking kind of contract. And where do I trust some other builder to tell me to do the work for me, and then I just like sign off on it? Maybe. And maybe that's actually like a totally fair way to, in a sense, get the best of both worlds, where you can have highly sophisticated actors doing really complicated work with like really high hardware requirements and network requirements and da-da-da-da. But it still gets kind of checkpointed or proposed by a decentralized set. Actually, in a certain sense, seems like a pretty elegant way where you get this sort of common community of Ethereum with some very high degree of decentralization, while having all the advantages of the Cosmos ecosystem, where like, what did my validator do for me? You can kind of make all those asks. They just sort of get outsourced. Maybe more complicated, but I think it does. It's a pretty interesting design.
Yeah, I think it is too. And I actually think I agree that it's inevitable that it's already happening with Eigenlayer. There was also, I'll plug another really interesting episode of Uncommon Core that Hasu and John Charbonneau did with Ansgar and shoot, I'm blanking on his other name. I'm really sorry, but it was a great episode on the sort of future of staking on Ethereum. And at the same time that we're starting to question like the role of what an L1 proposer ultimately should look like, there are a lot of big questions being asked around ETH's monetary policy and issuance. And if we were to target, a reduced a percentage of stake today, like how does that impact the validator set? I really do think there are some really fascinating questions going on. People are starting to question again, like what the role of the L1 proposer should be. And I don't know. I am a broken record on this, so I understand listeners of Bell Curve, you're just like, Mike, just shut up saying this, but it just really does feel like we're converging around, a similar perspective on what a proposer should look like across many different networks, albeit with really different flavors. And I would say it does feel like it's a meaningful distinction to me. We were talking about this a little bit off air, that the basic required specs for an Ethereum proposer is still extremely lightweight, so that if God forbid there was some sort of crackdown, that maybe we lose some functionality, but it's still like robust to a crackdown. And I really do think that's one of the things that Ethereum main chain has over some of its like beefier competitors, like the Celestias or Solanas of the world. Like I think the censorship resistant properties are stronger on Ethereum, the network. So I don't know. I think,
just to correct you before Celestia people hit you in the replies, Celestia does have really low hardware requirements, but I know what you meant, right? I know what you meant.
Celestia has low hardware requirements for their light nodes. They have really beefy validators on the main chain. But personally, just for Celestia folks out there listening, I actually think that's probably the most elegant design. Like I'm a huge fan of that. It's like, it's basically what we're saying. That's what we're asking here is like, hey, maybe to like really zoom out here for a second, which is dangerous to do right at the end, is to say, hey, like we want applications to run, but we don't want ultimately to be beholden to like one centralized actor that does that. What we're really asking is for a committee instead of one centralized entity doing an action. We want a committee of different actors to do that action. Like, what should those committee members ultimately end up looking like? One way to still maintain a high amount of functionality while asking a committee to do a thing is to do what Ethereum's doing. The base requirement is very low. A certain subset of that committee is going to opt into doing being like beefier. Celestia kind of bakes that in and says, hey, actually, these mostly we're just going to assume that like these are kind of beefier, but we have this nice measure thing called light nodes and data availability sampling that like obviates some of the risks around having fewer beefier nodes. It's just like, this is what I mean by convergence. It's all different flavors of the same thing. And so yeah, that's kind of
and we like Ethereum's flavor generally. I think it's pretty good. And I think it's actually like all this stuff is pretty good for value accretion to ETH too, which is a point I think you keep making, and it's a good one.
Totally. I also think that I think ETH is already kind of won in a sense. Like maybe this is a pretty controversial opinion. I think it could almost just sit on its hand and let the liquidity and sort of network effects take hold. I know we got to run here, Hart. This was a really fun one. This next episode, we're going to be talking with Kyle Samani specifically about network effects. I'm going to shout out C-Node, who keeps poking fun at podcasters who are asking, where does value accrue in the modular stack? C-Node, we're making this one for you, my man. We're making this one just for you.
Let's do it.
All right. Sweet, dude. This was a really fun one. I'll see you next week.
Next time. Bye.
Hey everyone, want to give a final shout out to this episode's title sponsor, Sei. Now, there are a whole bunch of really exciting reasons to be building on Sei V2 outside of just parallelization. I want you to head over to sei.io to looking into building on their public DevNet. Again, click the link at the bottom of this episode and head over to sei.io to start building something today.